will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too long. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me.
Welcome back to another day in 100 days of Rootkit. I hope you guys are feeling very, very classy, alright? Because I feel classy. You guys be looking a little classy, alright? We're learning for the last couple days, including today, how to be high class, alright? It's all about your appearance, alright? That's why I wear a suit and tie on all of these streams, alright? So I can give off the appearance that I'm high class, alright? That's high class 101. I hope you guys have got that message the last couple days. We talked a lot about classes, alright? Alrighty. So, let's learn more. And there we go. I was wondering why the music wasn't going off. Alright, so let's learn more today about classes, how to escape your current class, get into a better class, dodge classes, meet the cool kids outside of class. I don't know. We're talking about classes. Which class exactly? I'm just as confused as you guys, but don't worry. We'll get through it together, alright? We'll get through it together. Before moving forward, I need to let you know, we're Rootkit, nonprofit organization here in the US of A. Please let us be your tax haven, alright? We are charity registered in US of A. All donations you give us, tax deductible, alright? Don't give Uncle Sam your money, alright? I know what they do with your money, alright? I worked for the gov for quite some time. They're wasting it, I'll tell you. Have you ever seen a fire pit made out of money before? Alright? Well, that's the government. Alright? It would actually help people more, because at least they'd have some heat, alright? How much they go through that cash. For the dumbest things. Alright, for the dumbest things. Alright. You know what else is a waste of cash? That's right, colleges. Don't waste your time or your money on college. At least cash, we can print more of it. Colleges, though, will suck 4 years out of your 4 years from your life, and you will never get it back. It will just be gone. All right, those greedy little pigs. All right, do not go to college. Just get a cert, and then you can go get a job afterwards. Additionally, don't go to any other boot camp. They're scams. All right, they are straight up scams. You can look at their courseware content and ours. It's not even, we're not even playing the same game as them. They're still trying to figure out how to tie their shoes while we're running a marathon over here. All right, if you look, you'll see they'll cover about 1/4 of the content that we do. We closely align ourselves to what the current needs are in the job field. All right, so come, learn from the best. All right. Additionally, on top of all this free stuff we're doing, all right, 100 days of Rootkit teaching you guys, etc., etc., we got our week 7 giveaway. So if you go over to our site, actually I think, yeah, this one just ended right before the stream. So week 8 giveaway will go up live again. We're going to be doing mystery giveaways for the rest of the time. What is a mystery giveaway? Every single Sunday is when we'll be figuring out what the mystery is. So effectively, we're going to do a dice roll here on stream, and it will be correlated to different types of merch. And then whatever it lands on is the merch that we're going to be giving away. And then all entries are free. It's a completely free giveaway. All right. If you like what we're doing and you want to help support us, because doing things for free is very, very expensive. All right. Someone has to pay the bills to keep the lights on. All right. You can go over to this link. It's in the description of the YouTube video and of the Twitch stream, and you can donate. And when you donate, depending on how much you donate, you can unlock certain rewards like our stickers, this epic collab t-shirt here I got. Look at that thing. Look how cool it is. And our exclusive 100 days of Rootkit sweater, which is super, super epic. All right, super soft, heavy duty. It's heavy duty, all right? It's not some thin little sweater. That's all I gotta say. Additionally, all donations are being matched 1-for-1 for the first 10,000 donations, right? First 10,000 donations. And we have pillars along the way, like streaming for 24 hours straight. The shaving my head here live on stream, which would be very entertaining. And then the one no one wants to see, especially myself, shaving my beard. All right, if I shave my beard, I can't do these streams anymore because I'm going to lose all the, I shouldn't say all, the little bit of intelligence I have left, all right? All right, sweet. Let us move on. What's up, Destroyer? Nice of you to join. Matthew, where you been, man? You've been slacking. That's the answer. That's where you've been, slacking. All right. let's move on our journey through classes. All right. We've talked about classes. So recap so far. We've talked about classes. We talked about importing, the two different ways you can go about importing stuff. We using import or from, how you can change the name of an import with as, and then how classes can be inheritable. All right. And we talked about self, and then we talked about super. All very important items. Please, if you're not, we got one, cookies and milk came through. All right, cookies and milk came through in two ways, not just one. All right, it came through because they started supporting us on Discord Premium. So if I didn't mention, I am in the events chat over on Discord. So if you are a Patreon or Discord Premium member, you'll be able to just jump in there and ask questions anytime during the stream. All right, you'll have voice turned on. So Cookies and Cream came through and definitely accomplished and nailed the challenge. I want to see a couple more of you guys doing this, all right? Just a couple more of you guys completing these challenges because they are super important. We're telling you the things you gotta learn. We're giving you lots and lots of examples, but if you're not doing it yourself, you're not going to pass the practical. The practical is not a written exam, all right? We're going to ask you to make something and you have to make it, and you will be graded based off the rubric that is on the cert page. So if you go to the cert page, our rubric is there and it tells you exactly how we're going to grade your exam. Another question is you have to get 70% to pass. 70% to pass, right? It's not A, B, C, any of that stupid grade school bullshit. It's a pass or fail, all right? Because the real world things are pass or fails, all right? So it's just a pass or fail. You need 70%. All right. Yeah, decisions, you're in the same boat as us, right? Bank account on life support, all right? Those machines are expensive, all right? We're gonna have to pull the plug here soon. All right. Enough with death. Let's talk about a different type of death. Our mental death. So, lots of information that we've covered so far. It's all very, very important. You are doing it all the time. You are doing it every time you're programming in Python. It's not something that you may do all the time, but it's something that you need to know because depending on the language that you're utilizing, it's going to be more or less important, especially if you end up going to a company that is still using or manufacturing Java-based products. And I'm talking about not just Java, I'm talking about those people that are trying to revive it with Scala, all right? It's just Java at the end of the day, all right? It is slowly dying out, but that's probably the most heavily used and where all this will really, really, really come into play. Python, it's give or take depending on where you are, but you need to know this stuff because you're already messing with object stuff. Like I've showed you guys already when we, if I can get to it, our word guessing game. You've been messing with it the whole time with everything we've done because technically in Python, pretty much everything is an object. So let's learn our next concept here, shall we? Let's learn our next concept here. So if I pull up our good old cert, so if we go to the rootkit site, let's see, will there be multiple practicals? If I fail the first, will the next one be the same or different? There's a pool. Just like how there's a pool of hundreds to thousands of questions for the written exam, you won't be asked thousands of questions. You're going to be asked a fixed amount of questions. It's going to be the same for everyone, but the test is automatically generated for the written part. So it's going to be different for everyone. Same thing for the practical part. It's going to be different for everyone. Right now we have a handful of base applications, but the things inside of it are automatically generated, so it will be random for each person to a certain extent. We are continuously adding more and more applications to the pool. So no, if you have to retake stuff, most likely it's going to be different every single time. And I see the music thing is loud, so I'll turn that down a little bit. So let's go over to the comp sci cert here. And on the comp sci certs, let's go ahead and take a look over to our programming fundamentals. All right, programming fundamentals. Here we've already talked about inheritance, so we got to talk about encapsulation and polymorphism. All right. You're welcome, Kwai. Hopefully that's better for everyone for the music part. So let's do polymorphism first because it sounds more fun. All right, Python. So if we Google this, you'll get some examples. So if we click on the first example here, we can go and read the definition if you're not familiar with it. The word polymorphism means having many forms. All right. In programming, polymorphism means the same function name, but different signatures being used for different types. The key difference is the data types and numbers of arguments used in the function. All right. So let's go ahead and take a couple of looks at examples here. So here's kind of a example here in regards to functions and that optional argument that I kind of showed you guys. So there's a default way of how things are going to operate, and then you have the option to modify it. All right, you have the option to modify it. Let's see if there's a better example in here. So I don't think, okay, re-implementing a child method overriding a polymorphism. Let a user define in the child class that has the same name as the method in the parent class. Okay, this is what I was more so expecting. So polymorphism lets us define methods in a child class that have the same name as the methods in the parent class. Does this sound kind of familiar? Should, right? What was the assignment? What was the assignment? And you always have what class in Python? A init? That's right. That's right. You've been doing polymorphism the whole time, you didn't even know. Congratulations, we've covered this. All right, we covered this. It's effectively when you have the same method and you're going to basically remake it in a different class when you're inheriting it, but you're going to alter the original method, right? You're changing the original method to something else. So for example, we brought it up a lot yesterday. Bring that down. Our attack here. There's a normal version of attack, and then when we use super here, we're altering we're using the base one and we're altering it. All right. You don't have to use the base one for it to be qualified as polymorphism. As long as you are changing anything about it, you've written polymorphic code that is changing. All right. It's similar at multiple different steps, but the attack here works differently than the attack here, even though it's being inherited. All right. Any questions on that? Kind of a got you guys. Also, these all kind of just flow into each other. So not too much we have to go over or learn there, because we went over it a lot yesterday, and it was a part of the assignment. You are going to do it regardless, because if you are doing your init, remember, this is a special function, well, special method, but regardless, you're going to have one most likely for every class that you make, which means you're doing polymorphism all the time. All right, all of the time. All right. Any questions on that? I don't see any questions rolling in. So let's go ahead and move into the... Oh, what did we get? No, that was just a little bot spam thing. So let's go ahead and move on to the next item here. Encapsulation. Can Python do encapsulation? Encapsulation, here we go. Are we already doing encapsulation? Let's read this first part first. Encapsulation is one of the fundamental concepts of object-oriented programming. It describes the idea of wrapping data and methods that work on data within one unit. This puts restrictions on ascending variables and methods directly and can prevent the accidental modification of data. To prevent accidental changes, an object's variable can only be changed by the object's method. So this is, yeah, as you can see here, it's done with private variables. But I told you guys the other day, Python doesn't have any concept at all in regards to private and public. It is all public, period. There is no way to get around it. Everything is viewable by everyone at all times. All right? So there's some cheating that goes on. All right? Like I said, we're all lazy people here in the programming world. Lazy, copy and paste, cheating, it's part of the territory. So if you like any of that stuff, hey, you're in the right place. So let's see here. So I talked to you guys also earlier in regards to the underscore. All right, the underscore, one underscore in front of a variable's name does absolutely nothing for you. But it is a convention that's usually used for reflecting a private variable. All right, private variable, aka something that you're basically asking everyone else, hey, ignore this. All right, don't touch it. I know it's there, but I don't want you to touch it. All right. And what you'll do with encapsulation is basically make a middleman. All right, a middleman for messing with that variable type. Let me see if I can see it right here. All right. So you're basically making a middleman. I don't really like these examples, so we're gonna do one of our own examples. So let me see if there's anything else here we should talk about. So this stuff works. I personally, look, I like Python a lot, but I think Java and C++ and pretty much every other object-oriented language does this all better. It really does, all right? It really does all this stuff better than Python, but doesn't mean Python's not still epic, all right? Because it is literally the epicest language, period, all right? Get all these, where are these? Is anyone here doing front-end stuff? Get out of here, all right? Wrong language. No, I'm just kidding. I'm just kidding. All right, so let's go ahead and make a new class here just for the example. Sorry, I saw some chatting going on. All right, so we'll get to NPC, back to NPC in here in a second. I just want to start with a clean slate. All right, just clean slate. I'm just pressing enter a bunch just to move it all down. All right, let's make a new class and let's call this class, since we're sticking with the gaming theme, let's say your weapon. All right, this is your weapon class. This is what you're going to use to manufacture new weapons. All right, so inside of weapon class, we're going to have def_init. This should be starting to become very, very familiar to you. We're going to pretty much have an init every single time. And we need self inside of this. All right, so inside here, weapons are going to have a couple things. All right, they're going to have weight, and maybe their default weight, let's say, is, I don't know, 5 of what? I don't know. It's 5. That's all you need to know. All right, maybe sharpness. All right, sharpness is going to be a 0 through 1 item. All right, 0 through 1, aka that's going to correlate to percentage. All right, and let's just put one more thing in here just to fill it out a little bit more. Let's do length. Well, I guess it should have damage, right? Let's just do damage. Of course, there could be lots more items here, but we're going to just keep it simple right now. So I kind of showed you guys earlier that when we want to make an object from here, so let's go ahead and make an object from here. So let's import. So I'm back in main. We got some imports here. Let's just do a comma and say weapon. So we get weapon over here. And let's make a new weapon. Let's say this is going to be a sword. Sword's going to be equal to weapon. All right. So recap. Also giving you guys a couple seconds to catch up if you're typing along. In Classy, we're just, you guys can comment this stuff out from yesterday, or just push it down like I did, so just out of the way. The big thing is we just made a new class. Very simple, called weapon. It has an init in it, and we just made 3 different properties inside of it, right? Nothing crazy, just 3 properties, very, very basic. And in main, we're just creating one sword from that weapon class, right? One sword from that weapon class. So nothing super crazy. And let's just go ahead and print the swords. I don't know. Let's say the sword sharpness, right? Let's print the sword sharpness. Ugh. And if we see here, let me rerun this so it's a little more clear. If we see here, the sword's sharpness is 0.0 right now. All right, it's absolutely 0%. This is a butter knife. All right, the sword is looking like a butter knife right now. Right now, which is not something that's ideal. All right, usually you don't want this in this setup. What I mean by this setup, for example, a user right here in main.py can go in here and say sword.sharpness equals 10 million. We kind of showed this off earlier. So if I rerun this, now sword sharpness equals this very, very large number. We kind of showed this before about how anyone can now manipulate your variables because everything is public, right? Everything is public. So what are the workarounds, or how can you potentially go about fixing this? All right. Encapsulation is your answer, right? Encapsulation is your answer, because you only want sharpness to ever be between 0 and 1, and you may also want some like custom logic, because think about it. If you're making a game and someone has a sword, they need to take that sword to like I don't know, a rock or a grindstone or something, and then spend time sharpening it, and maybe like every 10 minutes they sharpen it. It only improves it by X%, whatever percentage you want for improvement. I don't know, it's your game, it's whatever logic you want. But the thing is, you might have thought of this logic and implemented it, but now you need to require people and force them to use it, all right? You need to force them to use it, because right now we can just go in here and cheat and say, ignore your fancy little logic and go straight into getting it so we just have an unrealistic large amount of sharpness, right? This would be extremely a problem in regards to attacking. If we were attacking with the sword and you did your damage calculation based off the sharpness, if there was a way to put in an obscene value like this, your weapons are going to be a little broken, just a little bit, right? Just a tiny little bit. So we want to stop this from happening. So how do we do this? How do we do this? If there's no concept of private, everything's public, like how are people programming this type of stuff in Python? Great question. All right, great question. It's through encapsulation and cheating. All right, the Python language has a bunch of ways to cheat in regards to doing this, and we're going to be utilizing it via, I don't know why they don't have any examples in here for it, for getters and setters. Right, getters and setters. We're going to go over those. Let's see. W3 schools failed us. That's all I gotta say. They usually have really great stuff. Let's see if this one got anything good for us. Nope. So they're saying that 1 underscore is protected and 2 is private. So I guess let's start with baby steps first, because 1 bit at a time. All right, 1 bit at a time. How do you... Let's prove that things that are private aren't really private. All right. So let's say the sharpness, we don't want people to modify it directly. Right? We don't want people to modify it directly. So we could do an underscore on it. All right. An underscore means, hey, don't touch. You leave it alone, please. I beg you. There's nothing actually protecting it. It's just you asking, like, please, pretty please, don't mess with it. Don't mess with it. If we go back over here to our main program and we say sword dot, if we look, we're going to see sharpness. All right, sharpness is going to be here. And if we say sharpness equals 10 and we print, I guess I shouldn't have deleted that line, sword dot sharpness, and we run this, oops, you'll see we still are able to change it. And if we did something like 2 underscores and we reran, I should probably change this one too, and we reran this, look at that, it also says 10. So even though everything you're going to read is going to be talking about private in other languages means that if we're here at main, we shouldn't be able to access or look at this thing. All right, it should only be accessible right here. There is no actual concept of private at all in Python. All right, it's all an illusion. It's all fake news. All right, just know this is just a way you can ask nicely and be like, don't touch it, please. Like, use the other thing that I have. What is the other thing that we have? What's the other thing that we can tell people to utilize instead? Great question. All right. Effectively, what you can do is use things like getters and setters in Python in order to help put rules around what custom logic you have. So let's go ahead and do Python getter and setter. Yeah, boy, we're getter setter. Where do you at? All right, there we go. This is what I'm looking for. Let's go and wait. Yeah, it's property and then setter. All right, so I'm gonna go and write this out. Now, stick with me. Don't worry. I'm gonna explain this. Give me like 2 seconds. All right, give me like 2 seconds. Actually, that's not too bad. We want to change the sharpness. Sharpness, and let's say sharpness right here, and then we'll say underscore sharpness, and then we'll say sharpness right here, and then we'll say sharpness, and then we'll do print. I'm currently sharpening. Okay, I can't spell, so we're going to go with that one for now. All right, and I believe this is, what am I missing right here? Expected function or class declaration after declaration. I did. What are you talking about? Oh, why you gotta do that? So when you're copying and stealing code from online, pay attention to when you copy it in, all right? Because sometimes the alignment won't be correct. So if you see here, I have 4 spaces, which is 1 tab for me here in my editor. When I copied and stole this stuff, you can see that it is 1 tab and 1 extra space, so 5 spaces. All right, so make sure you guys are watching that for that stuff, and you fix any issues that may occur. All right, so this should work. Let's run, see. It looks like it's working. What did I just do? Don't worry, we're gonna talk about it in like 2 seconds. All right, in 2 seconds. And you give me a second here. Position, but 2 were given. I mean 2. Oh. guess I can just remove this. The setter should work like normal. I guess that's because it should be like this. I shouldn't have deleted that line. There we go. All right. Let's talk about what just happened. All right, what madness did we just do? What were those @ signs? What is going on? Well, the title of class today is class magic. All right, so we're going to talk about some magic you can do. All right, this magic is super awesome and useful. So in Python, we have in a lot of different languages, you'll have this also. This concept of decorators. All right, decorators. That's what this @ sign allows you to do, is decorate something. All right, like you do Christmas, you know, you decorate your Christmas tree, or maybe you put lights on your house. You decorate it. So when you're decorating, you have something and you're putting decorations on the outside. You're adding new things to the outside of it. And when someone looks at that thing you've decorated, they'll look at the outside stuff first before they'll see the ornaments on the tree or the lights on your house before they see the house. Like, it's technically like more inside. Same thing happens here. This is actually like a function effectively that's going to have some custom logic potentially that will run first before your function runs. All right. In this case, this is going to be doing some special stuff for us. It's going to be making this into an attribute. All right. It's going to be making our function into an attribute. So when we do something like this, this is actually a function. All right. This is actually a method. It's the sharpness method here. And it's being treated like a property. So if we look here, sharpness itself is underscore sharpness, right? Underscore sharpness. It's in a private state, a hidden state, a state where, I mean, it's still public, but when someone tries to like look at it, they can basically see our little underscore, which is basically us saying, please don't mess with it. I beg of you. All right. So when they see that, they're going to be like, all right, I won't mess with it. Instead, they'll mess with the OG sharpness variable instead. What do I mean by that? If we look here and we do a dot, you're going to see this little wrench right here by sharpness. This wrench by sharpness. This means that this is going to potentially be a property or a variable that you can access, but has some underlying special functionality to it. What is that underlying special functionality? It's that it has this decorator on it called a property, which basically is going to turn this into a property, right? A variable of our object. Okay? So you can put any type of logic you want inside of here, right? Any type of logic you want at all. You just need to return at the end what this variable is supposed to be, what this property is supposed to be. So if you look right here, you can actually see that sharpness method called is going on right here. Sharpness method called, all right? So this, and it prints right here, 0.0. So right here is where we're doing our printing. Let me undo. There we go. Right here is where we're doing our printing, right? So we're trying to access this property. When we try to access this property, it's actually disguising itself as a property, but it's actually a method behind the scenes, right? This method is going to print this line out, which we can see it's printing this line out right here. And then it's going to return the value of underscore sharpness, right? And then when it returns the value of it, then it will print it here on the line, which is why we get 0.0. We're effectively making a middleman, all right? We're effectively making middleman to associate between us and the person wanting to do things, all right? So when someone wants to mess with sharpness, they have to go through the middleman, this property middleman, and they will discuss, and then the middleman will come to the other side, do whatever it needs to do, and then return a value. All right, this is in other languages going to be called a getter, because it's going to get the value of this variable. All right, it's going to get the value of this variable. This is called a setter. All right, it's called a setter because it's going to be used to set the value of our variable. All right, set the value of our variable. All right, if you can see here, A is what we're going to be getting when someone tries to assign a value. So this right here, this 10, is what we're receiving in right here at A. You can see here that we are assigning 10 to sharpness. We're assigning 10 to sharpness, but if we run this, you're going to see 0. 0 is outputted. 0 is outputted. Weird. We just said it should be equal to 10, right? No. You pass 10 to this variable, or right, to this property, but it's going to this special setter function here. All right, it's not actually being assigned to a variable, even though it looks like it. It's actually going here, all right, over to this function. When this runs, it doesn't save this value off anywhere. All we're going to do is say print I'm currently sharpening. All right, and if you can see here, we print out that statement I'm currently sharpening. Right, it's printing out I'm currently sharpening right here before we do this print right here. So that's why I'm currently sharpening is first, because it's going it's being set before everything else. Any questions in regards to that? This is the last like complicated thing we have to go over here. This is one of like 2 ways you'll commonly see people going about encapsulation in Python. We use super to grab from the parent package, right? Correct. From the parent class. What does function object has no setter mean? Function object has no setter. You gotta put these errors in the look. If you guys are getting errors in your code for now on, I'm not gonna answer them from the chat. You have to put them into the 100 Days of Rootkit Discord channel, because there's absolutely like no way we can continue answering these with little context around them. All right. So it's also a little weird here that the first one is going to be at property and the second one's going to be sharpness.setter. All right. Is there a... I don't think there is. I'm pretty sure it has to be property. Yeah. Pretty sure it has to always be property, if I'm remembering right. I usually just copy and paste my code. In regards to this, you can copy and paste the setup code anywhere. Just remember the proper terms for this is called getter. All right, let me write this. Getter. And this one is going to be called a setter. It's not called that. This is not called like, this is called a property at property here in Python, but in other languages it's literally called getter and setter. All right, Python's got to be a little different than everyone else. Again, this is how you can make custom logic, a custom middleman to handle when people try to see a particular value or when they try to set a particular value. We never made sharpness with no underscore. You can see here, sharpness with no underscore is made. How does it know sharpness without an underscore is what we want to do? It goes based off this function name that's attached to the property here. All right, this function name that's attached to the property is going to be what's used for our what do you call it? Our simulated property. All right, our simulated property here. So that's why sharpness here is why we see sharpness here. And this for the dot setter this sharpness needs to be the same name of this. All right. This function, I can't remember if it's required to be the same name of this one, but I'm going to assume it does. So make sure it's the same name in all three of these places. All right. This one's going to be a dot setter instead. This a, again, it's a variable. It's just like every other function / method that we've seen. It can be called whatever you want it to be. Now, if someone wants to sharpen their sword, and we only want people to be sharpening it from 0 to 100, or sorry, 0 to 0.0 or 1.0, all right, 0 to 1, then in here we can finish up our custom logic. Let's say this is the sharpen. Let's make it simple. This is how much they're going to sharpen by. So sharpen by, right? We don't want them to sharpen our stuff past 1.0. So what we can say here is we can put custom logic that says so we want to take sharpen by self dot sharpness. So also all the data is being stored here in the underscore sharpness. So basically, even though we're using sharpness here, it's interfacing and storing all our data here in the underscore sharpness, right? In the underscore sharpness. So if we go here and we say underscore sharpness, and we'll just make some bad logic per se. Let's add first. So underscore sharpness is going to be equal by sharpness by. So let's go back in our main here, and now this 10 will be saved, and we'll see 10 printed out right here. If we rerun this, you'll see there's 10. Again, there is 10. Additionally, if we do something like print sword dot underscore sharpness, you'll see that it's going to also show 10. Additionally, this protection is voluntary. What I mean by voluntary? If you're using sharpness, everything will be protected, but no one has to follow or listen to that. So if I say underscore sharpness and I say that's going to be equal to this number, you'll see that they've both changed that, because this is the actual property, the actual variable that is going to be storing the data, right? This is just the middleman, right? This is just the middleman. So if I remove those, all right, right now we have basically the same problem or the same logic we had before. So let's go ahead and modify this a little bit more so it does the protection we're looking for, all right? So we want, so if, let's make a temporary variable here. So let's call this temp. Temp is going to be equal to sharpness plus sharpen by. So that will tell us what our new total is going to be. All right. So if our new total, before we actually save it to underscore sharpness, if our new total is over 1.0, we just want to assign 1.0, all right, to our sharpness. If it's anything else, then we'll just let it be. All right. So we're not protecting against negatives, but that's fine for right now. So like I said, if our new sharpness is greater than 1.0, then we just want to set sharpness equal to 1.0. And then if anything else, we're just going to say, well, I guess we could put in just an else statement. I'm not returning right there. So else self dot sharpness plus equals sharpen by. All right. So now we finished up our custom logic here, our custom sharpening logic. So again, we're making a new temporary variable here just to temporarily hold what sharpness plus sharpen by is going to be equal to. Once we do that math, we're going to just do a quick check on it to see if temp is greater than 1.0. That's not a valid sharpness. All right, that's not a valid sharpness. So we're just going to say our sharpness is equal to 1.0. If anything else, we're just going to add sharpen by to sharpness because we know it's going to be less than 1.0. All right. And if we see this now, this should default to 1.0. This should default to 1.0 if our logic works correctly. And if we run this, you'll see, even though, let me clear this and run it again so it's a little bit more clear. Even though we ran this with trying to assign 10, we have set up our middleman properly, that getter and setter. We've set up our middleman properly to handle invalid data, right? Invalid data. That's the super awesome cool thing here. All right. And then if we did something else, like let's say 0.5, it should just be 0.5. So if we run this again, you'll see it's just 0.5. So it is handling oversized variables, or sorry, oversized data and normal size data properly. What questions do you guys have for this? I promise this is the last mind-altering, mind-breaking thing in programming we ought to cover. I mean, classes in general is the most mind-bending thing for lots of people. And we've pretty much just covered it all. We've covered all three big pillars of it. So just like Git, right? Just like Git, moving forward, we're going to get lots of practice with this, right? We're going to be doing Git a lot, and we're going to do classes a lot. So even if you are like really struggling right now to comprehend how you would go about it, that's fine. We're going to get lots of practice. Just try right now to understand the terminology. The terminology as in class is a thing. It's a blueprint, right? It's a blueprint that can be used to manufacture objects, kind of like our notes here, all right? When we say properties, those are just variables. They're the exact same thing, right? The exact same thing. Methods and functions, exact same thing. Technically, the only differentiation is going to be with self. That's the other weird thing. Self is a part of classes. Self means that this variable is going to be attached to every single new object, and it's going to be independent. They're not going to be like shared with each other. They're going to be completely independent from each other. All right. And know that there's these things called getters and setters. We can perform inheritance, right? And I think that was just about it. I'm trying to stall for anyone that has questions. I don't see nothing coming through. So I don't know if you guys' brains are just broken that much right now, or y'all understand it. Which, if you guys understand it, then that's golden. That's some good stuff then. I mean, you guys see this stuff all the time in your games. Like, there is, in all the games that you play, there's custom getters and setters attached to all of them. Because your stats shouldn't really go below negative, at least some of the stats, right? And when you add new stuff to the stats, you don't see them go past a particular cap, right? It would be really bad or broken if they could. So this type of logic will usually be the middleman for it. There's technically one other way you could go about it, and it's more of a hacky way. And that's by doing things like making functions here, or what do you call them? Methods here, that are just going to be like, I'm going to call it set sharpness. All right. And then another one called get sharpness. This is a completely legit and normal way to do it also. You could do it this way and add your logic inside. It would work just fine. This is not the most proper way to do it because Python has the ability to allow you to make getters and setters. But this is a way that people usually go about it, especially when they're at more of a basic level, or if you're doing something more like functional programming in something like C, Golang, Rust, etc. They'll have to do it this way because there's no concepts of objects in those languages. This is completely legitimate. We are doing the exact same thing. Again, we're doing the exact same thing with these. This and this are equivalent. This is just a nicer, fancier way of doing it. Let's see. Got error here. Function object has no attribute setter for class weapon sharpness dot setter. So make sure that this function name is set, sharpness, and this function name is sharpness, and that you have this one. Matthew says, I love OOP. I do too. I do too. I have to rewatch. Stepped away for a second. I'll have questions for tomorrow. Yeah, so tomorrow's our chill Q&A. All right, every Sunday is our chill Q&A. So come loaded with questions because those days last as long as you guys ask questions. So you guys don't ask very many questions, it's going to be done very, very quick. If you guys have lots of questions, we can answer them. It's pretty much free tutoring. So make sure you use it or you're just going to lose it and you're going to be lost in the sauce. OPP is awesome. So OPP, if you guys haven't already assumed and we haven't already talked about it, is OPP is object oriented programming, right? It's what we've been talking about all along. But programmers are lazy. No one wants to say object oriented programming. But OPP is epic. It's super awesome. It's a huge time saver, especially when you go about programming. All right, especially when you go about programming, especially compared to functional programming. It's just massive time savings. And it allows you to do more powerful things more quickly. And you're basically getting at different layers of abstraction, which we'll talk about most likely on Monday in regards to generations of languages and what language generations we're currently using, what are popular, because technically I'm going to stab any of you guys that say that C is not a low-level language. All right, C is a low-level language. Technically, if you go look it up, C, Golang, Rust are not classified as low-level languages. That would be for assembly, right? That would be technically assembly and below. Python, C, Rust, and Java are technically all on the same tier of high-level language. I don't care what they say. They're wrong, and I will shank you through this screen right now if you say elsewise. And we can see that when we talk about language generations, all right? In language generations, Python is distinctively different than C, all right? And that's how it should be. C is a lower level language than Python. I don't care what anyone else has to say about it. They are wrong, 100%, all right? Definitions for words are made up by individuals along the way. And I'm telling you right now, I'm changing the definition of it, and that's how Rootkit's going to be teaching it because it's wrong in its current state. No way you're going to tell me that fucking C and Python are both equal on the high level language tier. They are separate. They are separate. That would have been maybe an appropriate thing to say 40 years ago, 30 years ago. All right, I don't see any other questions right now. I don't see any other questions right now. So we're about around break. Hold on, Cote. Oh yeah, Yes, make sure you have these @ signs. These @ signs are vitally important. This is what makes the decorator a decorator, all right? This is what makes the decorator a decorator. You have to have these @ signs. You have to have these @ I'm going to say it again. You have to have these @ signs. They are what makes this a thing, all right? All right. So, we'll talk more about this here in a second. We'll maybe go over some more examples. There we go. We'll go over some more examples here after the break. So I'll see you guys in like 3 to 5 minutes. Alrighty. We are back. We got some stuff to go into, some more mind-shattering stuff. We're gonna get kind of deep All right, we're going to question reality as we know it. All right, not really programming reality. We're just going to talk about real world questioning reality and how it's the same. The fabric of reality is the same in regards to the fabric of programming. So there's this recurring theme that I've been mentioning a lot. I don't know if you guys have really like taken notice, but I'll just reveal it to you. All right. The reoccurring thing is that there's no rules or regulations or governance in regards to anything that you do in programming. You can name your variables pretty much anything you want, according to whatever rules were set up by the people that made the language themselves. All right. There's the way you make your functions, the way you can go about your programming, the way you can go about any of your logic is totally up to you. And there's like 1,000 different ways to do it, right? It may seem like kind of like heaven or maybe kind of like anarchy because it's absolutely crazy, right? It's absolutely crazy. Well, programming is absolutely crazy. You can take control and pretty much be God mode. But the thing is, it's the same way in real life, right? You may think there are rules or other things that govern your life, but there is absolutely nothing. There's absolutely nothing that governs what you should do on a daily basis. You choose to do what you want to do on a daily basis, whether that's attending school, following laws in order, or whatever you else want to do. You are only limited by the laws of physics and chemistry, which would be the equivalent of variable names and the layout of your code. All right, layout of your code in your program. Both realities, programming and real life, you just adhere to what you think is correct. All right, whether that's for your morals or whatever else you want to name. Same thing here. We have guidelines in programming we follow, right? And it's can be as restrictive or non-restrictive as you want. You can go about life in 1,000 different ways. Same thing with programming. You can go about programming in 1,000 different ways and come to the same solution or the same idea or the same result in programming in 1,000 different ways, and you can do the same thing in real life. All right. It's not because things are complete anarchy and chaos in programming. It's technically the same everywhere else. We just choose to follow guidances per se in real life. Those would be the laws. And we choose to do the same thing in programming. All right. And it comes down to that foundational trust. All right. Trust is very, very important, especially in the world today where it's ever most fleeting. All right. Are people overall less trustworthy than they were 20 years ago? That's a question you have to come up with the answer with yourself. All right. Because everyone thinks differently in regards to that. But it's the same thing in regards to the developer community and the open source community. Not everyone on there is going to do not. If anyone tells you that open source software, like we hit on this before, is trustworthy, then leave that person. They are absolutely insane, stupid, crazy. All right. They are just ignorant because the open source community is just like normal human society. There are bad actors and good actors. All right. Just because someone is big and popular doesn't mean they're a bad actor. For example, FTX, Sam Frankman, whatever his name is, SBF, very big in the news. If you don't know them, you should probably look it up and pay attention. All right. It scammed billions and billions of dollars from people. One of the biggest companies in the world, specifically for crypto. They can look good until they're not good, until things break. Same thing in the programming space. All right. Things can look good until they're not good. Do I have any examples of that? Sure. There's lots of examples. The only one that comes up to mind right now off the top of my head, you can find lots of these examples, is in regards to some, I forget the developer's name. He makes a very, very popular library for JavaScript. And I think it's Colors, and I forget what the other one is. It's open source software. People like Amazon uses it. It's open source and marked to be free for commercial use. So Amazon uses it without pretty much giving a dime to the developer because it's marked like that. The developer was a little salty, so he modified the code so it would break everyone that was using the repo. So Amazon software was broken because he decided to change his stuff. It's that easy. It's that easy to take down billion-dollar organizations because the people that run those are not special. They're not cool, unique, or any of that stuff. They are just like you. They are just like you. They have biases, loves, craziness, everything just like you, just like me. All right? They're no different. When they see some shit crypto coin go up, they're investing in it just as much as the next person. All right? They fall in the same traps as everyone else. They are not special or crazy. Crazy like unique that people like to think they are. So don't ever fall into the illusion that there's potentially safety. All right? What you have to do at the end of the day is find who you're willing to trust. Right? That's how the world runs, is on trust. So whether it's GitHub repos or people in real life, whether you trust us here at Rootkit to facilitate this education, or a company to be honorable to their message, it all relies on trust. Right? Trust is literally the fabric of everything, society-wise, programming-wise, etc. Right? So find things that you trust and move forward with them, but make sure you also do your research. All right? We already gave our speech in regards to open source researching and contributions, because if you're using and not helping, like how Amazon was using and not helping the devs at all of the code base they were using, even though it's not implied in their licenses they have to do anything, don't be shitty. Come on. If you put shit out there, you're going to get shit back to yourself, all right? And the world can't get better if we're all just taking advantage of each other. So let's take advantage of each other with each other, all right? You guys hop on our boat, and then we'll take advantage of people, all right? We're going to trick them into learning concepts like calculus, like how I fooled all you guys, all right? Idiots, all right? Fooled all you guys into learning calculus. And we've gone deeper in the calculus rabbit hole, and you guys don't even know. Don't worry. We'll do some more reveals here in a bit, all right? This is my orange juice. Oh, delicious. I love orange juice. All right, let us chug along here. I don't see any questions from the break. So let's go ahead and chug along here and talk about this a little bit more. So we talked about sharpness, but this can be applied to just about anything, right? Just about anything in real life, right? So, for example, your phone. It has a battery, right? It should have a battery. Your battery can only be up to 100%, right? Well, if you're going to make a phone in a game and you want to emulate having to charge it, all right, first off, holy shit, man, come on. Like, I'm trying to play a game to escape reality. I don't want to worry about managing my phone's battery life. But when you're doing that, that may be a good case for getters and setters, because you don't want people to overcharge their phone past 100%, and you might not want people to be able to hit negative percentages on their phone. That would be a little weird. So getters and setters would be a great way to, to monitor that. All right, to monitor that and to dictate what's going on. Let us see here. For our weapon. So, also, me. I am a human, right? Potentially, I'm a human. All right, who knows? Maybe I'm an alien. Maybe I'm a lizard person along with Mark. All right, good old Mark. But I'm a human, which is something that we could replicate in a class. We've already done it with our NPCs. This is a phone. This is a completely separate object, which we can replicate in our code here. You can have multiple different types of objects, which we've already seen get created with our NPCs, our player, our goblin, our weapon. They can also interact with each other. All right, it's okay to let them interact with each other. What do I mean by that? Well, a person could have potentially another class called, for example, class called a inventory. And a person could have an inventory attached to them based off this class. Because remember, technically everything in Python is an object. So this, again, we have those, it's been a while since we've done it. We're allowed to do typing in Python, all right? I'm gonna do it up here at the top. We can do typing in Python, which is gonna be our colon and then, what is this, an int. All right, and I think the way PEP8 likes it is like this. This is going to be our float. And then this is going to be our int. These are objects. Even though they don't look like objects or seem like on them, they are them in Python. And we're already using them here in our weapons class. So if we wanted the user to have a weapon on him at all times, we can do the same thing here in the player class. We can say something like self weapon equals weapon, and we just generated a weapon. All right, we just generated a weapon and gave the player a weapon. So we're now mixing together our objects, our custom objects, with some of our other custom objects that technically aren't related at all, but we can do that. We can do that. Just like how someone can have a phone on them, all right? This is where things can go potentially bad on you. And you won't know it at first. You're gonna go programming forward, maybe doing something like this, right? Because I didn't include the inventory thing, right? So the pitfalls for object-oriented programming that a lot of intro people get into, and we'll point this out when we make a couple new games here in the coming days, is that you want to spend some time thinking and abstracting concepts, because if you don't, you're going to run into some of these issues, and they're very common. If you run into them, that's fine, right? They're learning experiences. I run into them too at times, all right? It's good to sit and think for a little bit to try to figure out how exactly you're going to go about something. So what do I mean here? We have a weapon, all right? Player has one weapon. We can go about programming our game, and that's going to be fine. It's going to work, etc., etc. But what if we want our player to have two weapons now? Are we going to go in here and say self dot like weapon 2 and then weapon? Like, how are you going to go about that? So this is something that a lot of these pitfalls that you run into will be something that happens. You don't notice it was bad because you move forward and you program and things work just fine until you're like 3, 4, 5, 30 days into your project. And then you're like, ooh, I kind of messed that part up. And I used that in like 1,000 different places. So now like everything's all types of messed up. When in reality, you may have, if you thought about it a little bit more, you may have wanted to make an inventory system within inventory class, all right? Inventory. And the inventory class, all right, would be holding all of your weapons, cosmetics, etc., etc. And then on the player itself, you would, instead of having like weapon in weapon 2, you would say like left hand, like self dot like right hand, and instead in these hands they could hold a object that was in your inventory. All right, they would hold objects that are in your inventory. There's lots of concepts like this. In particular, we'll go through, I think the next thing we're going to do is going to be a banking system. All right, so we're going to make a banking system for a game, and we're going to show how important it is to think about it before you go about programming it, because you think a banking system would be easy, but then when you start using object-oriented program with it, you learn real quick there's a lot of ways to go potentially wrong with it. So doing that abstraction, right? That abstraction. So looking, analyzing, reviewing, and abstracting those core components out. Like, you got to sit there and like think. Like, a good example. We haven't hit the banking assignment yet, but let's throw that example out right now. If you wanted to clone a bank, how would you go about doing it? Oh, I would just make a bank class and then you would just do stuff with the bank. Well, is that the right way to do it? Are you sure about that? Banks are a little more complex than that. For example, you didn't mention anything about users. But now the next question is, where do users fall in this picture? Are users independent? Do users come sign up at banks? Do banks just have users? Like, are users like a sub item of banks? When a user goes to a bank and stores some items, are you just storing those items based off of the user themselves? Or do you want to introduce a concept of accounts? All right, you want to introduce a concept of counts? Well, now we have three classes potentially: bank, accounts, and the user or player. Where are the accounts attached to? Are accounts attached to players? And when they go to the bank, they show or reveal their account and the bank is able to like open it up? Or do the accounts belong to the bank and the player has to go to the bank in order to view inside of their account? And then what type of accounts are they? Are they just simple inventory accounts? Do you want to make, like, I don't know, mimic real world like stock market stuff? Maybe like do some type of grand exchange style thing where you have like the ability for users to trade items they put into that account with other people. Who facilitates that? Would the bank facilitate that? Is that a user post? These are all like questions and a part of the analytic steps you got to take, where you have to sit there and analyze, how do things even work? How do things even work? Some of this stuff, I would imagine some of you guys are very familiar with it. Maybe from your job, or maybe it's because you guys are just little nerds that geek out with your friends and talk about this stuff in regards to games, whether it's fair or not, whether it's balanced or not, how the game developer could be better about it or not, or how software you use on your phone could be better if they were to do this or X or Y. You're already performing these steps basically. So it's kind of just refining and getting experience with those steps so you can go about programming it correctly and typing out what you're thinking. Because it's easy to think, and then the next challenging spot is to translate what's in your head out onto your little fingers here and be a little keyboard warrior and type all this stuff out. Any questions in regards to that? The only way you get faster and better for that translation is by doing. So if I've stressed this a lot, I'm going to stress it more. Do. Program. Try. Do the challenges that we give, because they will help test and fortify what we're trying to accomplish here and get you into that groove. All right, get you into that groove, which is very, very important. All right, very, very important. No questions? Are you guys sure? Let me double check here. Cote says, I don't think that's orange juice. Oh, yep, it is orange juice. Oh, delicious. Tropicana. All right. Let me see here. So we pretty much nailed everything that I wanted to talk to about today. Are Are you guys sure you don't have any questions? Right? Are you sure you guys don't want to have any? You don't have any questions? We could finish up our example here in regards to player. Let's go ahead and do that real quick. So, using the code from yesterday, all right, where we had NPC fightable player, all right, we have our new weapon here, and our weapon has sharpness. It also has weight and damage. Now, I'm not saying any of this should be used in your game as is. We're just kind of throwing stuff up quick in order to show just how you'd be going about this stuff. I'm going to go ahead and just keep this as it is. So there's a weapon. And we're going to say our player has a weapon. Now, this is actually really something good to point out. If you ever find yourself naming stuff like this, weapon name, weapon damage, potentially attack damage is fine because it's only one item. It's particularly when you find yourself repeating a word and then something attached to that word. So weapon name, weapon damage. Maybe I had something else here that was called self.weapon durability, right? Weapon durability. This most likely should be a class. It should be a class. What should the class be called? Probably weapon. And weapon should probably have things like damage, durability, and name attached to it. So seeing that, we can also change on our weapon here. Let's go ahead and add self.name to our weapon. All right, in self.name, I'm going to have that name as a required item they need to say when creating a weapon. All right, so now we can go down here to player and say weapon, and this weapon by default they're going to get, I don't know, let's call this a dagger. Now we can completely remove weapon damage, weapon name, because it's all being handled by the weapons class. All right, and now we have a weapon object on our player. We can now use our attack methodology to not use weapon damage here, but use weapon dot damage. All right, weapon dot damage. Now if we run this, and this is going to be the player's attack, so we should make a player here. Player equals player. And our player should perform an attack. So let's say attack. So our player is going to do an attack, and our attack will pretty much output the damage they do. So if we run this, you'll see we're doing a damage of 20. And this is now being calculated based off of our weapon, which is from our weapon class that we made, our custom weapon class that we made. And we're calling this weapon a dagger. This can be improved further using things like getters and setters. For example, damage right here. Damage right here, we could keep this logic the same, but maybe we want the dagger's damage to be calculated, right? To be pre-calculated. So what we can do is use a custom getter for damage to calculate how much damage this weapon should do, factoring in sharpness, because we have that sharpness thing and we're not currently using it at all. So we can make a new getter for sharpness, or sorry, not for sharpness, for damage. So we made a new getter here. We copied and pasted and stole our code. Let's go ahead and get the setter code also, and let's steal that from ourselves. We need to do some name changing here, because we don't want it to be called sharpness. We want this to be called damage. So we'll copy that. We'll copy that there, and we'll copy that there. Remember, there's 3 places here with damage. Now that we have our own custom version of damage, we can't have this variable here called damage. We need to do an underscore on it. Make it hidden. All right, hidden. So once we have this damage variable here, we need to be assigning this its values and be recalling its value based off this. So if we look here at damage, we can see this is doing underscore sharpness. We want this to be damage. I'm going to say damage right here. And then this one is going to be, looks like it's fine. We just need to be able to save this value. So I'm just going to call this A. We need to save this off into the underscore damage variable. So I'm going to do self underscore damage equals A. There we go. So now we're properly setting, this needs to be down one. Now we're properly, we properly have a setter and a getter set up for this. All right, we have a getter and a setter set up for this properly right now. This should work, and we should get the same answer here because we haven't really changed anything. 5 is being stored. We're returning 5 directly, and we're setting 5 directly. We're not doing anything super fancy. So if we rerun this, you'll see 20 gets returned. All right? Nothing has changed. We're just now using a custom getter and a custom setter. All right? Custom getter and a custom setter. On our getter, we can return any value we want. We're saving our base damage into this variable called damage here, but we can return anything we want. So if we want to incorporate something, excuse me, like sharpness, we could say damage is going to be based off of, how should we calculate this out? Let's say damage is going to be times self dot underscore sharpness. So this is going to make it reduce it. Let's do a plus. Let's only reduce it if it's below 50%. So let's do that. And let's just put some parentheses to ensure order operations is happening properly. So what is going on here? Math. All right, you just gotta think it through. So what I have here right now, I'm not the best at math, but this should be correct. We have damage. Our damage is 5 right now. We want to multiply our damage against the sharpness. Now, sharpness can be anything from 0 to 1. What is 1 times 5? 5. That's right. Anything less than 1 in multiplication is actually going to reduce the value. So for example, if we bring up our handy calculator here and we say we have a damage of 5 and our sharpness is, so we do times 0.5 and we do that, I'll actually kind of do a Uno reverse card and be like, JK, I'm doing division. So 0.5 will give us 50% of what 5 was. So this would, we would actually always be doing reduced damage at all times compared to our normal base damage. So to avoid that, maybe that's what you want in your game, but what I'm doing instead to avoid that, 0.5 is being added to sharpness. So that way, if sharpness is ever at 0, it will be 0 plus 0.5, which means there will be a reduction of 50% on your damage. So 0 means 50% reduction in damage. I will also allow for, if they're at 100% sharpness, it will be technically 1 plus 0.5, which means it will do 150% more than the normal amount of base damage. So technically, you'll do more damage when it's super sharp and less damage when it starts getting dull. So we can, this is an easy way to have some variation in that. So now if we rerun this, you'll see we do 17.5 damage now. 17.5 damage. It immediately changed what our damage is. All right, immediately changed what our damage is. Why 17.5? Because we have a sharpness of 0. Since we have a sharpness of 0, that should half the value of 5. So that's going to be 2.5. All right, 2.5. So if we were getting 20 before, 20 minus 2.5, we got 17.5. So that means this was working correctly. We didn't have to, notice, we didn't have to change any of our logic here in player and for its attack weapon damage calculation, because this is using the new getters and setters that we've made. So we can now change code effectively in one place and then immediately see that it is being used everywhere else, right? Immediately being used everywhere else, which is super, super awesome. And we can see also if we change sharpness here to be something like 1.0, this should mean we do 150% damage. So if 5 is 100%, 7.5 should be 150%, right? So technically we should be doing 22.5 damage, right? If we run this, 22.5 damage. Epic. So now, based off sharpness of our blade here, they're going to be doing different amounts of damage. And this just continuously gets more and more complex based off the logic that you do, because we have this concept of sharpness, and I would assume every time someone wants to, let's say, do damage, the only time you would ever want to maybe like look at damage, or maybe when someone does an attack here, you can then degrade the sharpness every time an attack is performed. It's totally up to you on how you want to go about doing that logic, but then that's how you get some dynamic effects in your game going on. If we wanted to add something real quick, we'll add it right here. This is not, again, don't copy this stuff exactly how I'm laying it out, because I'm using it as example cases. This most likely is not where you want to add this logic in your actual game. But let's say every time someone wants to look at the damage the weapon has, which would, if you ever look at your sword in your inventory, this would be calculating and basically making it duller and duller every time. Maybe that's something you want, though. I don't know. I don't know what game you want to make here. But if we say self sharpness, so every time someone looks at the damage of your sword, we want to lower the sharpness a little. So we'll say minus equals 0.0. Well, let's just do something really, really drastic. Let's just do 0.1. So you'll lose 10% of your sharpness on your weapon every single time you look at your weapon. So if we run this now again, you'll see we were doing 22.5 before, and now we're doing 22 damage. And if we rerun this, we're going to see we get 22 every time, because it makes a brand new player with a brand new weapon. So to see this play out a little bit more, we could just put this into a for loop. So for x in range of 1. Let's do this 10 times. So let's see the weapon degrade over 10 different attacks. So if I save this and then click play, you're going to see that our weapon is starting here, and it's just degrading over time. It's degrading over time to 18 damage. So now we're properly incorporating sharpness, and our objects are separate, but now they're like properly affecting each other and having an effect on everyone else. All right. So I hope this is really getting the concept across to you guys in regards to getters and setters and why they're super important, why they work. Encapsulation is really, really cool and can be very, very powerful if done correctly. It can minimize your code changes. For example, again, like here in player, while you can make amazing dramatic changes in your actual code base for your game or application or whatever you're making. All right, we're doing lots of game examples, but this doesn't mean this is just applicable to games. This is not. This is applicable to literally everything. I'm checking here, seeing if there are any questions. What questions you guys have? Because that's pretty much it that I got for you guys today. Tomorrow again will be our chill Q&A. So we're going to chat, and then at the end of that session, we're going to poll our winners from the Week 7 giveaway. Additionally, at the end of this stream, the Week 8 giveaway will go live. All right, the Week 8 giveaway will go live. What questions do you guys have? Can you go back to Classy? Yep. Also, this print right here, if you haven't already figured out, is happening because of this print right here. So if we were to remove that and rerun this, you'll see that those prints won't be there anymore. Kamal, if you're trying to copy stuff, when the stream is over, the code's going to be in the supporter chat. So you can, with documentation. So you can just grab that. So you have exactly what I have here. Do you have any questions, though, before we call today's stream? So I guess for a challenge, I would challenge you guys to add a custom getter and a custom setter to your code, and then run something in main.py that's utilizing those getters and setters. All right, make a getter, make a setter, and then actually like run them, execute them, play with them. All right, try to assign a value, try to get a value. Are you guys going stay after in the supporter chat today for subscribers? We're in the supporter chat all the time. We monitor it 24/7. So anytime you have everyone that's in the supporter chat has prioritized what do you call it? Response times. So if it typically takes us, I don't know, 30 minutes to never to respond to someone in the supporter chat, it will take usually less than 30 minutes, and you will never not get a response. You'll always get a response. Yeah, for Patreon and Discord Premium subscribers, yes. If you have access, if anyone has access to inside of the supporter chat, they have priority access to us and responses from us. Yeah, when you're not in the supporters chat, yes, that is it. Yes. Yep, if you're not in the supporters chat, then you run the chance of us just never responding to you. Not because we don't see it, because we pretty much see everything, but we just we don't make the time to respond to everyone because there's just so many people. We can only prioritize paying supporters, all right? At times. All right, I don't see any other questions coming through. So, if you guys are a little confused at all, remember, you can always rewatch the stream. It's always recorded onto our YouTube channel. There are lots of other YouTubers that also cover these topics, so you can rewatch this from someone else if you would like. There's lots of ways to go about it, but again, practice. Make sure you're doing your practice. Make sure you complete the challenge that we've given you guys, and make sure you put it, if you did complete it, put it in the 100 Days of Rootkit chat. All right, everyone has access to it. Just drop it in there so we can see what you did, give you any, kudos if you did it right. If you did it wrong, then we can help you out. All right. Alrighty, that's all I got for you guys today. So I'll see you guys on the next one.